So our goal is to solve systems in 3 variables by elimination. So long problem. So it's really important that each step that we take, we're very careful with each of our steps. So, what do solutions to the systems of linear equations in 3 variables look like? If we have 2 equations, we'll do a little drawing of what we were doing before. When we would solve by graphing, which we don't solve by graphing when we get into 3D because it would just be way too complicated to do. But before, what we had was we would have our coordinate grid, and we would have an equation here, and we would have another equation like this. And then what was the solution to the system? Where they intersect. So this point right here would be the solution, because it has to be a solution to both equations. So any point on this line is a solution to that equation. Any point on this line is a solution to this equation. However, this is the only one that was the solution to both of the equations, which makes it the solution to the system. Okay? If we tried to do this in 3D, it would be really hard because we have 3 planes. Okay? So either our planes could be parallel, and then we wouldn't have a solution. We could have 2 of them parallel and 1 that intersects in certain spots, but that doesn't give us a solution. We could have ones that intersect but have this gap there in the middle, so that'll never have all 3 planes come together in one spot. And so there wouldn't be a solution to that. That's what it would look like. Now, I'm not going to give you systems that have no solutions or infinitely many solutions because it just gets too complicated. So I just want you guys to know that these do exist, though. When it has one solution, the independent system, it would look something like this, where the 2 planes intersect, and then the 3rd plane also intersects in that same spot. So it's still going to be a point, okay? One point will be the solution to that system. So these are the ones that we'll actually practice solving using elimination and substitution. Okay. Dependent, I won't give you any of them like that either. But if all 3 planes intersected at a line, we would also have infinitely many solutions. So you have these other possibilities, but I'm not going to give them to you on your assignments. Okay. Also, I'm not going to give you any of them that have like fractions and stuff. So as soon as you get a fraction, try to look for your error, because I'm going to give you nice numbers, because these are long problems. So I'm going to give you some good numbers to work with. Okie-doke? All right, so the first step when we are using elimination is to choose a variable to eliminate. Okay. Once you've gotten a variable that you want to eliminate, you're going to pair 2 equations together. And you're going to eliminate the variable from step 1. And then you're going to repeat that a second time. Okay? So you're going to do that step twice. So times 2. All right. Then once you've done that twice, you're going to have 2 new equations. So we're then going to write the system of 2 equations in 2 variables and solve. So what we're doing in step 3 is we're going to write the system. You'll have 2 equations. They'll be in 2 variables like x and y. Well, it looks just like what we focused on back in Unit 3. And from there, we can solve that because we've already done a lot of practice with systems in 2 variables. Okay, the system in 3 variables are what's new. So once we have this system in 2 equations with 2 variables, we'll be good to go to solve it. Number 4 says to use the two known variables. You're going to plug into an original equation to find the third variable. So you're going to have one of your equations from the beginning. We'll have 3 variables in it. You'll know 2 of them already. You'll plug in the 2 that you know and solve for the last unknown variable. Number 5 is to check your solution. Okay. So those directions probably don't make much sense right now because we haven't done it yet. All right, but that's okay. We're going to ignore those for right now. I'm going to walk you through it anyways, and these are going to kind of be like in case of emergency situation. You can come back and figure out, okay, what do I need to do first? What do I need to do second? It's good to have those in our back pocket. Okay, but first we're going to review how to solve a system in 2 variables using elimination. We practiced this for months back in Unit 3. So, first thing to do, make sure all your variables, your equal signs, and your numbers line up. Do your x's line up?
Yes.
Yep. How about the y's?
Yes.
How about the equal signs?
Yes.
How about the numbers?
Yes.
If I add them up right now, do any of the variables eliminate?
No.
No, I would have 5x, and then I would have 1y, so nothing would eliminate. So pick. Do you want the x's to eliminate or the y's to eliminate?
X's.
Okay, so if we want the x's to eliminate, what do you want 2 and 3 to turn into? Or what number can we turn them into easily?
6.
We can easily turn them both into 6. So we want one of them to be a positive 6 and one of them to be a negative 6, because when you add 6 and negative 6 together, it becomes nothing. It becomes 0. So it doesn't matter which one you choose to be positive and which one you choose to be negative. But if I multiply that top number by 3, 2 times 3 will give me 6x. 3 times negative 2 will give me negative 6x. And what I'm going to get here is, if I'm multiplying this whole top equation, remember you have to multiply every single term in it. So I have 6x minus 9y equals negative 33. In this bottom equation, I'm multiplying everything by negative 2. So negative 6x minus 8y equals negative 18. Now what I'm doing is I'm just going to add these 2 equations together. When I add them, 6x and negative 6x turn into 0x, which is nothing, and I don't have to write it down. Negative 9y and negative 8y is going to turn into negative 17y equals negative 33 and negative 18 add to negative 51. What do I do from here? Get the y alone. Divide by negative 17 on both sides. Negative 51 divided by negative 17 is going to be a positive 3. I have one of my variables here. I need 2 of them, though. I still need to find the x. What do I do to find the x? Yeah, plug in the y where there's a y. It doesn't matter if you use the first equation or the second equation. But we're going to take and we're going to say, okay, if I want to use the first equation, I have 2x minus 3 times y, which I know, equals negative 11. Well, y is 3. So I have 2x minus 9 equals negative 11. Add 9 to both sides. 2x equals negative 2, negative 11 and 9. It's negative 2. I still have to get x alone. Divide by 2 on both sides. That turns into 1x equals, what's negative 2 divided by 2? Negative 1. So there, now I have an x, I have the y. Because this was a system in 2 variables, when I go to write my solution, I write it as a point, x comma y. My x was negative 1. My y was 3. That's my answer.
That don't seem too hard.
Well, that's what we've been doing. We did that for months back in Unit 3. Right? So that one shouldn't seem too hard. That's just a review problem. Okay? That's only 2 equations and 2 variables. Today's the first time you're going to ever see 3 equations in 3 variables. Okay? But before we move on, let's talk about how we can check those. To check those, all you're going to do is plug them back into the original. So 2 times your x was negative 1, minus 3 times the y was 3, equals negative 11. All we want to do is put this first, put that left side right in your calculator. 2 times negative 1 minus 3 times 3. We get negative 11 on the left. There's nothing to type in on the right side. We just get negative 11. Does negative 11 equal negative 11? Yeah. So it works for that first equation. Okay, we need to make sure it works for both of these equations. So let's plug it into the next one. 3 times our x was negative 1 plus 4 times our y was 3 equals 9. Again, take your left side, since there's stuff to do, put it right in your calculator. 3 times negative 1 plus 4 times 3. We get 9 equals, we already had 9 on the right side. Does 9 equal 9? Yeah. Yep, so it works on that one. If it doesn't work when you plug it in, then somewhere in your solution you went wrong. Okay. So now that we've done that recap on what we did last unit, let's try one of our new problems. Are we ready? Solve the following system using elimination. Okay. So you now have 3 equations in 3 variables. Which which variable do you want to eliminate? Do you want to eliminate x, y, or z? So you get to choose one. Someone said x's, someone says y's, and someone says z's. There is probably an easiest choice. The y's would probably be the easiest choice. Because I can see, if I am looking at A and B, see how the y's are already lined up to eliminate? And if I look at B and C, the y's are also lined up to eliminate. So y's would probably be the easiest choice here. However, you can pick any that you want. It does not matter. So let's pick x, just so that we can actually see what we're going to do when things are not already set up for us. So let's pick x. On your assignment, you get to choose. Okay? For our notes, I'll choose. So then what you're going to do is you're going to pick, it says right in our steps, it says pair 2 equations to eliminate the variables from step 1. So what 2 equations do you want to pair? Do you want to pair A and B, A with C, B with C? A and B. So that can be one of your choices. What's your next choice that you want to do? B and C. Sure. Okay. So that's how we're going to label it. I'm going to combine A with B. I'm going to combine B with C. If I add up, so if I look at just A and B right now, if I add those up, do your x's eliminate? What's x and x together? 2x. Does that eliminate the x's? No. So what I need to do is I need to get these so that they'll eliminate. Which one should I multiply, A or B or both? It doesn't matter, but you only have to multiply one of them, right? What do you want to multiply one of them by? Okay, so you want to multiply A by negative 1. So like what I like to do is write negative 1A, because that's what I'm going to do here. I'm going to take A, I'm going to multiply by negative 1. And what I get is negative x plus y minus z equals 1. Because I know this is such a long problem, I double check each step before I move on. So I'm combining A with B, I'm using A, I'm making it an opposite of what it was. So my x's became opposite, my y's became opposite, my z became opposite, my negative 1 became opposite. That was A. My B I'm going to leave alone. So I'm going to make sure when I copy this down, x plus y plus 3z equals negative 3. Double check that you wrote it correctly. A lot of times the mistakes here come from just writing something inaccurately. X, y, 3z, negative 3. Looks good. So we're going to add these up. And what happens when you add them? The x is going to cancel out, which is good because that's what we wanted it to do. Okay. How many y's do you have? 2y. 3z and negative z make 2z equals, what's 1 and negative 3? Negative 2. So that's going to be one of my equations I write right in here where it says write the system of two equations in two variables. This equation is just in two variables. So I have 2y plus 2z equals negative 2. That's one of my equations. Now I'm going to do something very similar, but this time I'm going to combine B with C, because that's what you guys chose. You could have done A with C also. It does not matter. Let's actually do A with C so we can see what happens. Okay, as long as you do a different combination from what you had here, you'll be golden. Okay, so if I'm looking at A and C, are my x's going to eliminate? Because remember, that's the variable I chose that has to eliminate. Does x and 2x cancel? No. So which one are you going to have to multiply? A or C? Which one do you want to multiply? A by what? Negative 2. So what I'm going to have here is negative 2a, and I get negative 2x plus 2y minus 2z equals 2. Let's double check that I multiplied everything by negative 2. Multiply by negative 2, you get negative 2x. Multiply by negative 2, you get positive 2y. Multiply by negative 2, you get negative 2z. Multiply by negative 2, you get positive 2. That looks good. Then I have that. I'm not going to do anything with C. However, sometimes you do have to do something to both of them. But in this case, we only had to do anything to one. Make sure I wrote it down right. 2x minus y plus 2z equals 0. Looks good. Now I'm going to add it up. How many x's do I have? 0. So I'm just going to cross those out. I don't have any x's. How many y's do I have? 1 y. How many z's do I have?
0.
Nothing. My z's actually canceled 2. And 2 plus 0 is 2. So I actually get here y equals 2. When two variables eliminate, it's awesome because it's less that I have to do. Okay? I already solved for one of my variables, which is very cool. If I had like a number here in front of y, that's okay too. Just finish solving and get y alone. So my other equation here is y equals 2. Okay? We're going to take a break there, and I'm going to give you guys some time to do that to the two problems on the assignment right after our break. Okay, so now that you've done parts A, B, you actually can right away write C. What you end up getting in part B, the last step in part B, becomes your part C. Okay, so we rewrote this, we rewrote that. A lot of times, this ends up being another equation. Okay? So you could have something that looks more like this review problem from the front page. This one here, where you have two equations, and you have to go about solving it using either elimination, or if you want to use substitution, you could use substitution. Okay. For this one, though, since one of our variables is actually already solved for, right away what I would recommend doing is, I know that my actual solution is written in as a point. So I'm going to have x, comma, y, comma, z with parentheses around it. I found y. Where does y go in my point? The first, the middle, or the last? The middle. So I'm going to automatically write that 2 in there because I already found my y. Okay. Now, when I'm solving, I can choose whatever method I want to use here to solve my system of 2, because that's review. I don't care how you solve it as long as you can solve it. In this one, I would recommend substitution, though, since you already have one of your variables. So, I was looking to see what color it was supposed to be in. So to solve, I know that if I have y is 2, I can just substitute that in for y. 2 times y is 2 plus 2z equals negative 2. And from there, I'm just going to get z alone. So this is 4 plus 2z equals negative 2. I'm just working at getting z alone. So get rid of the other terms. So subtract 4 on both sides. (2z) equals negative 6. What comes next? Divide by 2 on both sides. Z equals negative 3. Oh, look, I have another variable. Where does that one go? In the first spot or the last spot? Last spot. So I have z as negative 3. Now, once you have 2, that's okay. That's easy. You just go back up to your original equations and plug in the 2 known variables to find the unknown variable. So what equation do you want to use? A, B, or C? And it does not matter. You get to choose. You want to use C? Okay, so we'll use C. So in equation C, we have 2. X is the variable we don't know. The last variable to find is the one that you originally eliminated. Okay, so we have 2x minus our y value plus 2 times our z value equals 0. Minus the y was 2, the z was negative 3. Okay, now we just have to work at getting x alone. So we have 2x minus 2 minus 6 equals 0. So what should we do?
Add the two coefficients.
Combine like terms, right? So 2x minus 8 equals 0. Or you could have added 6 and then added 2 to both sides. Doesn't matter. Okay. Either way, now that you have it like this, you're going to add 8 to both sides. 2x equals 8. Divide by 2 on both sides. X equals 4. Now that we have that variable there, we can fill that one in. We have our solution. From there, we still have to actually check our solution, though. So what we're going to do is just like we did on the front page when we had 2 equations, but now we have 3 of them. So for A, we're just going to plug everything in. We have x, which is 4, minus y, which is 2, plus z, which is negative 3, equals negative 1. Take your calculator, plug in the left side. Tell me what you get. So you should do that now. Use your calculator. If you don't have one, make sure you go trade your phone for one because you're going to want one. Plug in the left side. When you plugged in the left side, you should get -1 equals, the right side was already one number, so we don't have to do anything there. -1 equals -1. Does that work? Yep. So A gets a check mark. Now we have to try it with B, and we'll also have to try it with C. So with B, we have X, which is 4, plus Y, which is 2, plus 3Z, which is -3, equals X plus Y plus 3Z equals -3. Just double checking everything. From there, type in the left side. 4 plus 2 plus 3 times the -3. The left side is -3. Does -3 equal -3?
Yeah.
Yep, cool, it worked for B. Almost there. We have to check C, and we're hoping if it worked for 2, we hope that it works for that third one, otherwise we're in trouble and we got to find our error. C. All right, 2 times the X value minus the Y value plus 2 times the Z value equals 0. The X value was 4. The Y value was 2. The Z value was -3. Plug in the left side. Zero equals 0. Does that work? 0 equals 0? Yeah. So we did it. We found the solution and we checked it, so we're confident that that's our final answer. Okay, that's how you're going to finish out that problem. So you guys have the rest of the time to finish up those last couple steps, D, E, and F, on that assignment, and then you guys will be good to go.
Ready for work?